In this video, we're going to be talking about confidence intervals. So remember when we were talking about inferential statistics, we said there's kind of two basic ways, hypothesis test and confidence intervals. So now we're going to be talking about confidence intervals. Basically, this is kind of a different way of approaching things, kind of from the opposite direction. And so you kind of think of this as finding an interval estimate. So a lot of times we think of a point estimate. So that is, for example, if you want to find kind of like the average income from a group of people. That's just one number, 1 point estimate, just the mean or median income from a group of people. But that might be subject to some sort of error. So for example, if you were to take a random sample and find the mean, that's one number summary. It's a point estimate. But just due to the randomness from the sample, you might suspect that it might be subject to some error, and so you might want to have an interval estimate that kind of takes into account a measure of the error that we might expect. All right, so we a lot of times build like these 95% confidence intervals. It could be 80, 90, 99. So that percentage can vary. But what does it mean to build a for example 95% confidence interval? Well, that means that we are 95% confident that the interval contains the true population value. Remember that what we're trying to capture is that true population value. There is, for example, in that population, there is a true value for the mean of the population. And so we don't know that value. We have a sample, but we're able to kind of try to estimate it. And so we can use that point estimate, and then we use for example, a 95% confidence interval to get an interval estimate, so that we are a certain percentage level, confident that the interval contains the true value. One thing to note is that we're kind of treating this population value as fixed, right? So it's not, it doesn't vary, right? It's just at a fixed point. We don't know where that is. Our intervals that we're generating can vary. There's it can be a little bit higher, a little bit lower, a little bit wider, a little bit narrower. So it can vary, but basically these intervals, about 95% of the time we would expect these intervals to contain the true population value. Right. So these are kind of wrong ways that people commonly interpret 95% confidence intervals, or just any confidence intervals. So there's a 95% chance that the true population value is inside the interval. Now remember, we're treating that population value, that true population value, as fixed. And so it's not that there's a chance that it's inside the interval. It's that the intervals that we create, 95% of the time will contain that true population value. There's a 95% probability that the interval contains the population value. So again, the same thing. This isn't about kind of like a probability that it's in there. We're 95% sure of the sample statistic. This is not true, right? So we know what the sample statistic is. We're using that sample statistic, that point estimate, and we're building the interval around it. And also, it isn't that, for example, that 95% of the data are within this interval. So what we're trying to look at is we're trying to get an interval estimate of our population value. In this case, the example that I've been talking about is mean, right? We want to get a population. We want to get at that population value of the mean. We don't know what it is. So we're going to get an interval estimate rather than just a single point estimate. So for our sample, we have our point estimate of just the mean, but then we want to have that measure of margin of error. All right. So the way we can kind of think about it in terms of constructing this interval is, if we were to repeat the process of sampling many times and generated confidence intervals in the same way, 95% of those would contain the true population parameter. Right. So again, as I've mentioned before, the population parameter is fixed, and we are not assigning a probability to what it is. Right. And so this is kind of a graphical representation of what that might look like. So basically, you have each of these horizontal lines, these blue lines, represents a different confidence interval that was created, and that one red one is the one that doesn't contain the true population value. So here's 25 of them. Only one did not capture the true mean.